Okay, so welcome to lesson 7.1. This is graphing sine and cosine. And so this is, again, as I demonstrated on the board earlier, what your cosine wave looks like starting at 1 and 0, or 0 and 1, or y equals 1 here, and my sine wave starting at 0. Now, what I didn't talk about was the period. The period is what it takes for the sine wave to return to its origin point, or where it started. And so for cosine, I started at 1, I end at 1, and so the length of the space between those we call the period. And then the same thing for the sine wave, I started at 0, and I'm moving on to 0, and so that is the period there is also it's going from the starting point to the starting point. And for both of these, the period is 2 pi. And that makes sense, right? Because that's one trip around the circle is 2 pi. So that, again, that makes 100% sense. Okay, so this video in here, I encourage you to watch it on your own. It's about 8 minutes. Most of you have watched it already. I'm not going to play it right now, but I will leave a link to it in Canvas as well, so you can watch it on your own. But it's a good graphic as they demonstrate how you go around the circle, and you're starting here. This is starting at 0, so this is that sine wave and how it's generated. So how are the unit circle and the sine wave related? Well, to sketch that basic graph of the sine and cosine functions, we could, as we did on the board, lay out a graphic here. So where is sine when x equals 0? Well, on my unit circle, I'm at the starting point, and so sine of 0 is 0. At pi over 2, I'm at 1. Pi, I'm at 0 again. 3 pi over 2 at negative 1, and then back to origin. So I'm going to take that back to the Cartesian plane, lay that out, and again, is starting using for my x values, I'm going to put my radian values, or pi over 2, pi, 3 pi over 2, and then 2 pi. So here's my period starting to ending at 2 pi, and plotting those values for the sine function, starting at 0 and going up, down, and then back up to the origin again. Same thing for the cosine function. The only difference, of course, is my starting point is at 1, but the curve's length and arcs and such are all exactly the same. They're just shifted by pi over 2, or 90 degrees. So graphing that sine function, if I wanted to put some more points in there other than the maximum and minimum points, I could do that. And so what that would look like, putting them on the graph, where am I at 0? Well, I'm right here. At 30 degrees, I'm at 1/2. So let's go ahead and plot this out as 1. So 1/2 is right about here. Pi over 4, I'm at radical 2 over 2, which is about 0.7. And then 60 degrees, I'm at radical 3 over 2, which is about 0.8. And then we know we're at 1 for 2 pi over 2. And then the whole thing just starts going back down again. So radical 3 over 2, radical 2 over 2, 1/2, and then 0. So, and I'm not going to plot all of these. You kind of see the point now. And again, connecting the dots now, I get a better curve than I did just showing you the other, just showing you the pi over 2 and the 3 pi over 2. This same curve is going to continue down this way because what's happening on this side? Well, at 7 pi over 6, I'm over here. My y value is negative 1/2. And so that's why my curve dips below right here. At this point, I'm at negative 1/2. Negative radical 2 over 2, negative radical 3 over 2, etc. You guys don't need me to repeat all that. So that's the sine function. Cosine function is exactly the same. I'm just starting at this point. And remember, cosine is my x values, and my x value starting point at 0 is 1. So I'm here at 1, and then radical 3 over 2, 1/2, and you can see as I'm going this way, my x value is this dashed line, gets smaller and smaller as I go up, all the way until I get to pi over 2, where it is 0. So again, plotting this graph. I'm going to come down and then back down this way. Okay, so that's where our graph is oriented. Let's throw some letters and numbers in here so we can talk transformations. So again, if I have this function y equals sine x with the various transformations, then this is what that equation would look like. Okay, again, my parent function is sine x, and my transformations then are going to be created using these different letters. And so amplitude is the first thing that we're going to shift. Okay, so amplitude talks about stretching this thing vertically. So this is the a value in front of my sine. So whatever my sine value came up to, I'm going to multiply it by a. So that could, if it's 2 or greater than 1, it's going to stretch it. Okay, so instead of going up to 1, I'm going to go up to a times 1. So if a is 2, then my amplitude is 2. I'm going to go up to 2. So it's a vertical stretch. And I'll show you this in graphs later. Okay, but this is just like we did with any of our other transformations, right? If I put a up there, it's either going to stretch or compress it vertically. Same thing for the cosine function. And then the next thing is the period. We calculate the period with this equation right here. So the period is 2 pi over b, okay, and then which is the coefficient of x. And so this is the b value here. This is going to shift my period. And so if b is 1, remember that the period from our function before was 1 trip around the circle. And so that was 2 pi. And so if I multiply that value in front of here by b, then that period is going to shift by a fraction created. So it's 2 pi divided by b. And I'll explain this a little bit more later. A phase shift, in other words, I'm shifting left or right. That is going to be the c value there. It shifts me either left or right, a horizontal shift. And you'll notice, just like our polygons or absolute value functions, any of them, it's x minus c, right? It used to be like x minus h, but in here we're going to use c to prevent any confusion in terminology. So it's x minus c, so it's negative. And so if you have it x plus c, x plus some value here, then it's a shift left. But if it's x minus something, it's a shift to the right. In other words, it's the reverse of what you'd normally expect. And then a center line shift, either up or down, is d. And so again, I'm going to just, whatever my answer is, I'm going to add d to it. And so that's going to shift me either up or down d. So it's going to change my center line from 0 to either up or down. And again, this is just like adding k to the end of your function for an absolute value shift. Okay. So even though these things look a lot different with different letters and such, the transformation should be very familiar to you. Okay, we've done these, lots of these. That's what Algebra 2 was all about, was these different transformations. So we're going to start off easy and just find the period and the amplitude. Okay, and we didn't talk about in the previous slide, but a negative value is just going to inverse the function across the x-axis, or reflect it across the x-axis. So for here, my amplitude, remember that amplitude is the absolute value, so it doesn't care if it's positive or negative. My amplitude is 3. And I'm just going to write amp for short. Amp is 3. And then my period, remember that the period is 2 pi over b. So what's my b in this equation? Well, it's 1/3, right? So b equals 1 over 3, because that's what this is, right? B is the coefficient of x. And the coefficient of x, this is 1/3 times x, so b is 1/3. So then I would find my period by taking 2 pi, dividing it by, not by 3, but by 1/3. Okay, and so when you have a fraction in the denominator, we flip it and multiply it, so this becomes 2 pi times 3, or 6 pi. So that is my period, 6 pi. All right, let's try another one. So, and then of course this is reflected. It didn't ask for that, but just keep in mind that the amplitude is an absolute value of A. So the amplitude is 3, not -3. It's just 3. And then you could also say it's reflected if you want. It didn't ask for that, but just so you understand what the negative does. You do not have to write that on these when you do the homework on them. Okay. Let's see over here. So then this is really easy, right? My amplitude is just this number. In this case here, amp is 1/2. And my B value is, so if this is pi over 3, then my period is 2 pi divided by pi over 3, which one more time is 2 pi, if you will. If you want to write it out this way, it's 2 pi over 1 times 3 over pi. This is very common, so just get comfortable doing this. So the pi's cancel out, and you're left with a period of 6. So keep in mind that on my graph, and I'm just going to kind of sketch one real quick. On my graph in here, when I graph these, typically I'm going to have these listed as pi over 2, and then pi, et cetera, right? Well, just keep in mind that pi has a numerical value. Just because it's an irrational number doesn't mean it doesn't have a numerical value, and you could approximate that at 3.14. So if my period is 6, it's going to be just shy of 2 pi, right? So this is 2 pi. Then my period would be right here at 6, because 2 pi would be 6.28. Okay? So don't let that fact that there's no pi in there throw you off. Okay? That's totally going to happen a lot. Okay? So not a problem at all. There's no requirement for you to use the pi as your graph. You could use 1, 2, 3, 4, 5, 6. In a case like here, that's what I would do. All right, and that's why some of your graphs on the back on the notes guide and the homework, some have the pi's in there and some do not. Okay, on the homework, I don't think they have anything at all. You'll have to write them in yourselves. The spacing you choose to use and all that is completely up to you, whatever's going to make it fit on your graph. Let's try a couple more examples in here. So period and amplitude again, I have no A here. It's just a -1. So my amplitude is 1. Yes, it is reflected across the x-axis. My B value, 2 over 3. So my period is 2 pi divided by 2 over 3, which is 3 pi. Okay, again, I'm just going to flip this. The 2's cancel, 3 times pi. All right, I don't think I need to do any more of this. This is the same thing. Sine, cosine doesn't matter. If you want it for your notes, this amplitude is 1/3, and the period is 2 pi over 8, which is 1/4 pi. Okay, so that's really tightening it up quite a bit. Let's sketch some graphs, because why not? Okay, we'll start with the sine function without anything in here. And so I'm going to go ahead and just plot some key points in here. So if I start at x equals, so this is my x value, and so my other column here is sine x. Can you read that there? Is that too faint? Maybe we should go red, a little darker maybe. Let's try that. So this is sine of x. This is my y value column. So again, I start off at 0 and 0, and we know this because we beat this horse to death. This is 1. This is back to 0, -1, and 0. There are some key points in here. So all I'm going to do is plot these key points. So 0, 1, 0, -1, and then back up to 0. So my graph huzzah, not too bad. So, and if you look at this value, remember my amplitude equals 1. So I only go up to 1 or negative 1. Okay, that's how high it is. This is what that amplitude means. It's this maximum value in the vertical direction from origin. And then I have b value is also 1. So my period is 2 pi over 1, or just 2 pi. Okay, so and here we're asked to graph the cosine function. And so now we've got it. Now that I got a graph on here. Again, this is cosine x, and we know we start at 1 and go down to 0, negative 1, back to 0, and then up to positive 1 from a full period. So again, my amplitude is 1, my period is 2, and so my graph is going to look like this. And just continue on. Let's put some transformations in here. All right, so the first thing I'm going to add is an amplitude change. Okay, so I didn't give myself a handy table this time, so this will be interesting. Let's try this. Maybe we can see these both ways here. So here I have y equals 2 cosine x. So my amplitude equals 2, and my period is still b over 2 pi, right? So period is 2 pi over 1, or 2 pi. So that doesn't change. So then my x value and my 2 cosine x. Now, if I go back to my original cosine function that I had here, I know that at 0, cosine equals 1. So my transition here then is at x equals 0, 2 cosine x is going to be 1 times 2, because I'm multiplying it by that amplitude. So this is going to be 2. And then at pi over 2, I'm still 0. 0 times 2 doesn't care. It's still 0. At pi, I'm back to negative 2. And then pi, 3 pi over 4, or over 2, I'm sorry, is back to 0. And then 2 pi, I am at my origin, which is 2 again. So plotting those out on this graph, I'm starting here at 2, 0, negative 2, 0, and back to positive 2. So the only difference here is I've literally just stretched this graph out. Instead of going up to 1, I'm now going up to 2. Instead of going up to radical 3 over 2, I go up to radical 3, okay, et cetera. So if you wanted some more points in here, you know, at pi over 4, for example, that's 45 degrees, right? And so that's radical 2 over 2. But I double it, and so it became just radical 2, which is about 0.14 or so. Okay. I don't need to plot any extra points in here. You guys have got this one. Let's try another problem here. So again, the first thing I want to do is calculate the amplitude and the period. Okay, so my amplitude here is 1. And my period is, since b is pi over 4. And so my period then is 2 pi divided by pi over 4. So that one is going to give me a period of 8. So I'm going to do one full rotation here, not at 2 pi. Should actually get rid of those. My period is 8, right? So that's one full rotation. And so one thing that I could do is mark this period as 8. Let's just go ahead and do that. This would be 2, 4, 6, and 8. Let's do it that way. And yeah, that works out. So my period is 8. What I want to do is divide that period into 4 parts. I'm going to do it by 2. So 2, 4, 6, 8. So x and then sine x and then sine pi x over 4. All right, so I started off at 0. Sine x would normally be 0. And so all of this is going to be 0, right? So this is still, when I put a 0 into this, that doesn't matter what I multiply it by, it's still 0. So my starting point for this one is 0. So I have no phase shift on this at all. All right, so now what happens at pi equals 2? So let's do 2, 4, 6, and 8. Remember, I took my period as 8 and divided it up into 4. That makes my math easier. What happens at 2? Well, if x is 2, this just becomes 2 pi over 4, or pi over 2. Well, we know that pi over 2, at pi over 2, x equals, or pi sine is 0, right? Oh, I'm sorry, sine equals 1. And so in this case here, my sine value is going to equal 1. At 4, it's just pi again, right? And pi is 0, so my pi x over 4 is 0. And this is back to -1, and then back to 0 again. So those key points then are 0. At 2, I'm 1. At 4, I'm back to 0. At 6, I'm at -1. And then at 8, I'm back to 0. So my graph looks just like my sine graph. The only difference in this one is instead of this being pi over 2, it's now at 2, right? Instead of being at pi, it's at 4, okay? Because my period has changed because of the b value there. All right, more shifts. So in this shift here, I've got 4 cosine x plus pi over 4. So let's talk about the transformations and such. First thing is, what's my amplitude is 4. And my period is actually, I don't even have to do any calculations. My period is 2 pi. Because there's the b value. This is not part of the b. Remember, this is c over here. This pi over 4 is c. This is going to be a horizontal shift, left or right, so that has nothing to do with the period. The period is just the b value, and in this case here, b is 1, so 2 pi divided by 1 is just 2 pi. But I do have a horizontal shift, and now this is plus, which means my shift is to the left, pi over 4. Because I'm shifting left or right now, I'm not starting at 0 anymore. And I have to find what that interval is. And so this is the equation I'm going to use for that, is x plus c equals 0, right? Because that was my old starting point, was at 0. And so x plus c is going to give me that starting point. Well, c in this case is pi over 4. So x plus pi over 4 equals 0. So my new starting point then is x equals negative pi over 4. So let's put some points on my graph. Let's call this negative pi over 4. And I'm going to take that period and divide it up into 4 components, right? 4 points. If you want, you could also calculate the ending point of this. Let's do that. The period is 2 pi, and so the ending point here is going to be x plus c equals 2 pi. Again, so x plus pi over 4 is 2 pi. And then my ending point, or my period, ends at x equals, and then 2 pi minus pi over 4 is 7 pi over 4. So if this is 0, I don't know if you can see that. Let's put, and that's all I need to go. That's my ending point. Okay, I probably divided this up into way too many components, but there you go. That's my ending point. So now I'm going to put my graph in here, or my table, I should say. And where are we with each of these? And so at X and then my Y value, I'm not going to write this whole thing out. This is my Y value right here for cosine. All right, so the other thing, but before I do anything else, I got to remember that on my table here, my amplitude is 4. So I'm not going up to 1 anymore. I'm going up here, let's call this 4. And then down here is -4. So where do I start? My starting value is going to be right here when X is negative. Oh, you can't see that. When X is negative pi over 4, this is negative pi over 4, right? So X is negative pi over 4 plus pi over 4 equals 0. There we go. That's why that is at 0. So cosine of 0 is 1. Come on. Cosine of 0 is 1. So then 1 times 4 is 4. So this is my starting point at 4. I thought I had checked that out. Okay, and then so if I go to positive pi over 4, then that becomes pi over 2, which is 0. So this point here is 0. My next point, again, adding pi over 2 to it, is going to be 3 pi over 4. And here I'm at -4. And then at 5 pi over 4, I'm back to 0. And then 7 pi over 4, I'm back at +4 again. So let's put those on my graph. Y equals negative, or X equals negative pi over 4. Then Y equals +4 here. Okay, and then at pi over 4, I'm at 0. 3 pi over 4, I'm at -4. 5 pi over 4, I'm back to 0 again. And then finally up at origin. So this last problem has a couple of different transformations in here. So we have a vertical shift up 2. So whatever else happens in here, we're going to raise the result by 2. So that's our D value. And then you see we have a reflection. So we're going to inverse the result of the Y before we add the 2 to it. So you have a negative here for reflection. There is no A value, so A is 1, so our amplitude is 1. We're reflected. And then for our period, our B value is 2 pi over 3. So then we can find our period. Period is 2 pi divided by 2 pi over 3, which after the algebra, this becomes just 3. So we want to break this up again into 4 sections. And so I'm going to take 3, divide that into 4 sections. And so if I start here with my X value of 0, and then my final value is going to be 3. That's my period. So I break that period up into 4. So like half would be like 1.5, right? 1.5, and then 0.75 here, and 2.25 over here. So in other words, I'm going to go up by 3 over 4, right? 3 over 4, and then 8 over 4, etc. So, excuse me, 6 over 4. Okay, so that is the X values I'm going to use for my period or my key points. And so let's just start with a sine of X, and then let's build on that. So sine X, I put, because I'm using a 0 value, if it would have been, it doesn't really matter because sine X is the same. But, okay, so I put 0 in here. I've got, this is sine of 2 pi x over 3. And you can see now why I chose these points, right? So 0 goes into this, x is 0, and so this whole thing is 0, and of course sine of 0 is 0. At 0.75, or remember that's just 3 over 4, if I put 3 over 4 here, you end up with pi over 2, and sine of pi over 2 is 1. Now don't worry about the rest of this. We'll get to the rest of this in a second here. Okay, this is the equivalent of 6 over 4. And so if I put 6 over 4 in here, that would be 12 over 12, or just pi, right? And then so sine of pi is 0 again. And this is -1 and back to 0 again. So that's the typical numbers you'd see for a sine wave with an amplitude of 1. Now, I did say that this is reflected, and so this is where we're going to go ahead and put the negative sign in. So what does that do? It just flips each of these, right? Well, 0 doesn't change. This is now -1, 0, +1, and 0 again. And now my last shift is the +2, right? So I'm just going to add 2 to everything. So 0, 1, I'm sorry, not 0, it's just 2, right? 0 plus 2 is 2. So we'll fix that. So this is 2, 1, 2, 3, and then 0 plus 2 is 2 again. So these are my key points. So basically, I've shifted everything up like I normally would, but I've shifted it up 2 spots. But let's go ahead and plot this on our graph now. So on my graph, I'm going to start at, this is now, if this is 0, and let's go up, let's say this is 1, 2, and 3. Okay, that's my max value. And this is 0, so we're going to just go ahead and break this up. This is my first point, which is 3 over 4. And that's 1.5, or so let's just call it 1.5. It's easier to write. 2, 3, 4. This is 2.25. And this is 3. Okay, so 2 and 1. Oh, over here's 1. Down to, back up to 2 again, which is kind of 2 is our new 0, right? And this is up to 3. And back down to our starting spot. So my graph is going to look like that. Okay, so everything is just shifted up. Normally I'd be here at 0, but I just shifted up +2. Here I'd be at -1 down here, but I shifted up +2. Okay, so that's all these two transformations do to us, is I just take whatever my result was, I make it negative, and then for the d value, I just add or subtract, but it's positive, so I'm going to add to shift everything up. Okay, so that's all the different types of transformations and combinations. Let's look at doing this backwards here. So on this graph on the blue, I have a function. I know it's either sine or cosine, but let's look at it deeper. What can I tell about this? Well, I have an amplitude here of 1, right? Because of my max and minimum value. So amp equals 1. And I have a period, it's 2 pi, right? So that didn't change either. So 2 pi is the period. So really, this hasn't changed at all. This is just a function, so y equals sine x. Okay. Let's look at a transformation to that now. So this function here starts at 0 again, so it's sine. Now, it could be cosine with a shift of pi over 2, but we're just going to assume that it's sine. Now, I go all the way up to 2, so I have an amplitude of 2. And my period here is still 2 pi. Okay, so period P equals 2 pi. So if pi is 2 pi, and so therefore it's B equals 1. Okay, because 2 pi divided by 2 pi is 1. So in this case, then my function is y equals 2, right? That's my a, my amplitude, 2 sine x. Okay. And then now let's do the green. So the green one, amplitude is 1, but my period is pi. So if the period pi equals like 2 pi over b equals the period pi, okay? So then b is 2 pi divided by pi equals b, so b equals 2. So, and that totally makes sense to me. So then y equals, and again, I started at 0, so it's sine 2x. So that's how you can interpret these by looking at the graph and figuring out what the function is. Look for the amplitude, look for the period, and look for the starting point. If it started up here at 1, it would be a cosine function. Okay. All right, yes, there are ways to manipulate sine and cosine so they mimic each other. If I had inversed it, started at 1 with a phase shift of negative pi over 2, that would have made it look very similar as well. So yes, there are multiple ways to make these things look like each other, but we're just going to go with the simplest answer first. I use a little Occam razor here. So simplest answer is the solution, and so if it starts at 0, just assume that it is sine x, and then build it from there. Okay.